Alright guys, so a couple of things. You'll probably want to put headphones in on this because the microphone doesn't always pick up great. Sorry I couldn't be there today. I'm going to do my best to go over this lesson. I failed to print off a copy of this worksheet whenever I left school yesterday, so I'll be doing it on a notebook page, and it'll correspond with your sheet, so you can just kind of fill in as you go. Alright, the last thing, at any point in time my dogs may appear on camera and or bark, so if that happens, it might take a second because this is just going to have to be shot one take due to the limited technological capabilities that I have at home. Alright, so today we're going to be looking at a little bit more factoring. Alright, so factoring polynomials. So we worked on this a little bit the past 2 days. The good thing is today is just kind of summing up those and introducing the sum or difference of cubes, which is not too difficult. It's a couple of formulas which I'll give you here in just a second. Okay, but starting up at the top left corner of the page, you have a little box there, and it says first things first. Alright, so we always want to look for a greatest common factor, okay, a GCF. So we always want to be looking for that whenever we are trying to solve these problems. Alright, so for instance, right below that we have a couple of problems. Alright, and at any time if you want to try these without me, just pause the video before I go on, and that way you can take a look at it and see if you are doing pretty good. Alright, so the first one we have 12x to the third y minus 27x to the fifth y. Alright, so if I'm looking at my coefficients, both of them can be factored by 3. So I can pull out a 3. Alright, if I'm looking at both of them, I can factor out, we have x to the third here and x to the fifth here. So I can pull out x to the third. And then I have y here and y here, so I can pull out 1y from both. Okay, so if I pull a 3 out of 12, I'm left with a 4. If I pull an x to the third out, it's going to be gone, and if I pull a y out, it's going to be gone. Alright, if I pull a 3 out of 27, that's going to give me a 9. And then I pulled out x to the third, so that leaves me x squared, and then there's nothing left there for y. Alright, so let's take a look at the next one. We have 6x cubed plus 18x squared minus 12x. Okay, so all terms have a 6 in common and an x in common. So we can factor out a 6x, which is going to leave me with x squared plus 3x minus 2. Alright, because if we pull a 6x out of 6x to the third, it just leaves me with 1, and then x to the third becomes x squared, 18 becomes 3, x squared becomes x, and then 12 becomes 2, and then the x goes away. Alright, so if you look over to the right side here, okay, it says there are 3 options for factoring. So if we have 2 terms, there are 2 things that we are going to be looking at. Either a difference of squares, DOS, which is a little bit further down on your page, difference of squares, or sum or difference of cubes. Okay, SODOC, sum or difference. It'd help if I get the thing on the page. The sum or difference of cubes. Okay, so those are the 2 things that you're going to be looking at, and that's also further down on the page if there's 2 terms. If there's 3 terms, you want to make it 4. Okay, that's what we were doing yesterday as part of our steps. Alright, we want to make it 4 terms in order to better factor it. And if it's 4 terms, then we want to solve by grouping. Alright, so if it's 4 terms, we want to solve by grouping. Alright, so we did this yesterday, but let's run through it again today. Okay, so my perfect squares, this is going to be 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, and we'll stop there. That's 1 through 12. All right, most of you probably know that. Now, perfect cubes, this might be a little less familiar for a lot of us, okay? So 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed is 216, and we could go further, but you have a calculator at that point. So I would definitely know 1 through 4, and 6 doesn't hurt either. Okay? So let's take a look again. Yesterday we worked with difference of squares some, day before that, so you guys should have a little bit of an understanding here, but we'll go through this again. Remember, for my difference of squares, okay, the formula for this is a squared minus b squared, and that's going to be a minus b, a plus b. Alright, so some things that sometimes I like to do is go ahead and looking at my two terms. So for example 1, we have 9x squared minus 16, and figuring out what a and b are going to equal. Okay, so if I have 9x squared, what did I have to square to get 9x squared? Well, to get 9, I'm going to have to square 3, and to get x squared, I'm going to have to do an x. So a would be 3x. Alright, what did I have to square to get 16? Well, that's 4, so b would be 4. So once you figure that out, you can just plug it into our little formula here. Okay, so 3x minus 4 and 3x plus 4. Okay, and so that would give me 9x squared minus 16. Alright, example 2, I got 4y to the 4th minus 81. Okay, so again, a, what's going to give me 4y to the 4th? Well, 2y squared would give me 4y to the 4th. And then b, what's going to give me 81? That's going to be 9. Alright, so 2y squared and 9, 2y squared and 9, and 1 has to be positive, and 1 has to be negative. Sorry for writing that so small. Alright, you have 4 problems right here. I would advise you to take a second, pause the video, and then give those a shot. If not, I'm about to start on them, so either way. Okay, but I would advise taking a second, seeing if you know how to do this without my help. Alright, so let's look at number 1. We have x squared minus 25. So a is simply going to be x. B is going to be 5. So I would have x minus 5 and x plus 5. And remember, the order you put these in doesn't matter. It could be plus 5, minus 5, or like I've written it here. Okay? So let's look at number 2. Alright, so a is going to be 2x, and then b is going to be 7. So to make my parentheses, 2x plus 7, 2x minus 7. Alright, now 3, I threw you a little bit of a curveball. Okay, so remember, up at the top, the very first thing we wrote was always look for a greatest common factor. Okay, so if I look at 3, I see that both of these have a greatest common factor, something that I could pull out of them before I even begin this problem. Okay, so we could factor a 5 out because I don't have anything that I can square and get 5. So if I factor out a 5, I'm going to get x squared minus 25. Okay, at which point my answer would be 5, and then I would have x plus 5 x minus 5. Okay, so slight curveball there. Always make sure you're paying attention for greatest common factor, especially something like that where you know there's nothing I can really square to get 5. Alright, 4, we have x to the 4th here, so a is going to equal x squared, and then 1, so b equals 1. So x squared plus 1, x squared minus 1. Alright. Alright, so let's look at the difference of cubes. Okay, so pause this video for a second and write down these formulas, okay? Because we either have the sum of cubes or the difference of cubes. Alright, so if we have the difference of cubes, which would be a cubed minus b cubed, that's going to equal a minus b times a squared plus ab plus b squared. Alright, the sum of cubes, a cubed plus b cubed, equals a plus b times a squared minus ab plus b squared. Alright, so again, just like with above, once we find a and b, we just put them into these formulas. Okay, so it sounds tricky. It's pretty simple once you get going with it. Alright, so let's take a look at example 1, 27x cubed plus 8. Alright, so the first thing I want to do is figure out my a and b term. Okay, so what cube gives me 27? Well, we talked about that up here. That's going to be 3. Okay, and then I have, x cubed here. So a is going to be 3x. And then what cubed gives me 8? So that would be 2. Alright, so this is a and b. Now, is it sum or difference? It's sum. So I'm going to have a cubed plus b cubed. So that's going to be a plus b. So I'm simply going to put 3x plus 2. Alright, because that's the first part of that equation. And then I need to fill out the next part. So a squared. So 3x squared is going to be 9x squared minus ab. Alright, so 3x times 2 is going to be minus 6x. Alright, and then plus b squared. So plus 2 squared, so plus 4. Okay, so it's just following along with our formula. So let's take a look at example 2. So example 2 is going to be a difference of cubes. Alright, so again, we want to write a and b. So for this one, a equals y, because we just have y cubed, and b is going to equal is going to equal 5. Okay, b equals 5. So again, we want to go to our difference of cubes this time. A minus b, so y minus 5 times a squared, so that's y squared, plus ab, so that's going to be plus 5y, and then plus b squared, so that's going to be plus 25. Alright, so you have two examples, x cubed minus 1 and 8x cubed minus 64y cubed. Pause the video, take a second, give these two a shot, and then once you've finished them, turn it back on and see if you can, see if you got those right. Okay, I'm going to go ahead and start these now, so if you want a second, pause it. If not, just follow along. Alright, so a is going to be x, and then b is going to be 1. It's a difference of cubes, so I'm going to have x minus 1, then we're going to have a squared, so that's x squared, so minus, difference, plus ab, a times b, so that'd be 1 times x, so plus 1x, or x, and then plus b squared, so that's plus 1. So that was fairly simple whenever you have an x and a 1. Alright, last one. So we have 8x cubed, so that's going to be 2x, and then 64y cubed, so b is going to equal 4y. Alright, so this is also a difference of cubes, so I'm going to have a minus b, so 2x minus 4y. Alright, and then a squared, which is going to be 4x squared, plus ab, so that's going to be 2x times 4y, so 8xy, and then plus b squared, which would be 16y squared. Alright, so let's move down to the grouping method. Alright, so we got 4 problems here. Excuse me. So again, we've worked on this a little bit yesterday and the day before, so this should just be a little bit extra practice. So you could even pause the video real quick and see if you have this down, or you can follow along. Alright, so here we go. So remember, we want to break this into 2 parts. Alright, so what can I factor out of x squared minus 2xy? So I can factor out an x, which is going to give me x minus 2y. Alright, and then what can I factor out of x minus 2y? I can factor out a 1, which leaves me x minus 2y. Alright, so again, I want to take what's in front of both, so x and plus 1, so that's x plus 1, and then x minus 2y. Alright, let's look at the next one. So that's example 2. So I have x cubed plus 3x squared plus 4x plus 12. Alright, so let's group these. My dog is not really happy with my math at the moment. He keeps sighing. Alright, so I can factor out an x squared from both. So x squared. And that would leave me with an x here and then a 3 here. Alright, here I can factor out a 4, so plus 4, and then that leaves me with x plus 3. Remember, if you do this correctly, the terms inside the parentheses should be the same. So we want to take that, so that would be x plus 4 and x plus 3. Excuse me, x squared plus 4 and x plus 3. Alright, last 2. So I have x cubed minus x squared plus x minus 1. So again, group these. So I can pull an x squared out of both of these. So x squared, which leaves me with x minus 1. Here I can pull out a plus 1, which will leave me with x minus 1. And so I would get x squared plus 1 times x minus 1. Alright, lastly, x to the 4th plus 2x cubed minus x minus 2. Okay, so let me group these. So here I can pull out an x cubed, which is going to leave me with x plus 2. Here I can pull out a negative 1, since they're both negative, and that would leave me with x plus 2. Okay, again, you might wonder, well, how did you know to pull out a negative 1 there as opposed to just pulling out a positive 1? Well, if I had pulled out a positive 1, which I could have done, this would have been negative x minus 2. But we want it to be the same as this one. And so in order to do that, I need to factor out a negative 1. And so for my answer, x cubed minus 1, and then x plus 2. Okay? So, Miss Underwood is going to be in there, I believe, for a little while. She may even go over some of the notes. She was telling me that she has another method that she teaches. You are more than welcome to use her method if you feel more comfortable, okay? I am very much about finding the best way to solve the math problem for you and using that method as long as it works every time, okay? So if you like her method more than Mr. Rabo's method, be my guest. Okay, you're more than welcome to use it for this. All right, there's a worksheet on this. After you finish, you get to color if you have some colors. If not, just work the math, and then she will be giving you a quiz review. I plan to have the quiz tomorrow. We will go over a lot of stuff before the quiz, discuss everything so that you feel comfortable. I might even ease off the quiz a little bit with the complexity just because I'm not there today and wasn't there yesterday. So I know some of you are going to have some questions that won't be answered, and I apologize for that. So we will figure out some way to help you out on the quiz. But you do need to be working this stuff. You do need to be studying, okay? Everything from the exponent rules that we started on Friday and went over on Monday to what we are going through today, okay? Notice the word problem type things on the quiz review, all right? Those were some of the more difficult ones we talked about, dealing with the perimeter and the area and stuff like that. Go over those. Those are in your notes from a few days ago, okay? And again, we'll spend some time going over this tomorrow. I hope this video and everything works out. Otherwise, I spend a whole lot of time for nothing. Hope you guys have a good day. Please be on your best behavior. And this will be up on PowerSchool for a while if you want to go back and take a look at it. All right? Have a good day, guys.